we use the command Hadoop space fs-cat and then write the complete path of the file. So which file? ba.txt. So write the path user slash cloudera slash ajay slash ba.txt. Just type the file name, press enter. Right? So these are the contents of a file. So these are the contents of the matches played in the last World Cup, all the matches. Right? So this is the command Hadoop fs-cat. Okay. Now I'll take another simple command, ls command. Okay. So far we have completed cat. Next I am going to teach you ls command. ls is a command which is used to list the files, right? So this we have seen previously. So this ls commands will take the three parameters. One is ls-d, another one is ls-h, and other one ls-r. It will take the three parameters. So if you write ls-r, it will display the directory wise, subdirectories, and files in the directory. So it will display the complete contents of a file. ls-h will display the size in kilobyte format. ls-h will display in kilobyte format. ls-d will display in a plain line format, right? Like ls and ls-d, both just we use to display the files. But if you want to display the content in a kilobytes size, the size of the each file should be displayed in kilobyte size, kb size, then use the command ls-h. Suppose I'm taking the terminal. So to clear the screen, the command is cleared. So if you write Hadoop space fs-ls -r, r indicates recursively. So now it will display recursively all the files in the Hadoop file system, saying capital R. Okay, it will display all the files along with the file name. I'll list the Ajay directory. So I'm writing user, then Cloudera, and the directory is Ajay. If you press enter, see it will display all the files and the date and time and size and the privileges, username, and a group name. I'll teach you in the next command about these users and groups. Okay, so this is ls-r, where r indicates recursively. So it will display the folder, that is directory, and any subdirectories and any files. So it will list the complete list. So the same thing, if you want to display the size in kilobytes format, then write ls-h. Okay, now see previously it's in the bytes, now it is displayed in the kilobytes format. Okay, and one parameter ls-d, right? So it's a like ls command, Ajay directory, and the privileges, right? So ls command will take these three parameters, and ls is a command which is used to list the files in sdfs. So if you want to list the all the files in sdfs, then write hadoop space fs-ls. Suppose you want to list all the files in a specific directory, then you have to write the path here. Okay, So now I'm going choosing next command. Okay, so you see mkdir, right? Already we have seen this command. Mkdir is a command which is used to create a directory. Simple. If you write Hadoop space fs hyphen mkdir and give the directory name, the directory is going to be created. Okay, after that, already I teach this command in the previous session, copy from local. I'll repeat this command again. So copy from local is a command which is used to copy a file from the local file system to SDFS file system. That is, if you write ls, see here I am having a file. The file name is input.txt. Where we are in, suppose if you run pwd. Right now I am in the directory home cloudera. So in a home cloudera, I have a file input.txt. Now I want to copy this input.txt to the directory test789 which is in SDFS, right? So the command you have to write is Hadoop space fs hyphen copy. From is a case sensitive, f is a capital letter, copy from local, l is a caps 1, copy from local, and specify the file name. Which file name you want to copy, right? Suppose here I am copying the file input.txt. So write here input.txt. Okay, now specify where you want to copy, right? I want to copy to the directory test789. And remember, in Cloudera, every user file, every user directory by default created in user Cloudera directory. So if you write usr, then Cloudera, okay, and the directory which is created test789. Okay, now specify the path where I want to copy the file. Press enter. Right now the file is copied to the which directory test789. How we check whether the file is copied or not? Just run the ls command, that is hadoop space fs hyphen ls, then write user, then cloudera, then test789. Okay, so now the file input.txt is copied to the directory test789 which is in SDFS. So the copy from local is a command which copies a file from the local file system to SDFS file system. And the similar way we have another command, it both works the same. That command is hadoop space fs hyphen put. Put also works as a copy from local, where both are used to copy the files from the local file system to SDFS file system. Suppose now here I want to copy another file, right? So here I am choosing the file, uh, right? cities1.java. So write the file name cities1.java and specify the location where you want to copy the file. I want to copy this file to user, then Cloudera, then there is a directory test789. Press enter. Right now cities1.java is copied to the test789 directory. Now how to check? We can check with the command hadoop space fs-ls. Right, so run this command hadoop space fs-ls, then right we got the file cities1.java is copied to the test789 directory. Okay, right? Similarly, so here either copy from local or fs-put. Both commands are used to copy the file. Suppose I want to move a file. Move a file means it's like a cut paste. Copy from local, put command works as a copy. And we have another command, that is Hadoop space fs hyphen move from local, right? It moves a file from the local file system to SDFS file system, right? Suppose here I am checking a one, choosing a file, file 4, right? I want to move this file to the SDFS directory, that is I am writing file 4 Hadoop space fs hyphen move from local, and then write the file name which you want to move. Here I want to move the file 4. Where I want to move? I want to move this file to user, then slash cloudera slash test 789. Now press enter. Okay, now this file 4 is moved to the test 789. To check that, now I'll run ls command. We won't find here file 4, right? And we'll find this file 4 in which directory? Test 789 directory. If you write this command Hadoop space fsfn ls, then test 789 we can see the file 4, right? So the three commands, one is copy from local, and put command, and move from local. So these three commands will copy files from the local file system to SDFS file system, right? Suppose we have a situation where I want to do the reverse. I want to copy the files from the SDFS to local file system. Yes, can we able to copy? Yes, we can able to copy. Now we have to use the reverse, means now copy from local will copy a file from the local file system, right? So the reverse for this is copy to local, right? What it will do now, it will copy a file to the local file system from SDFS, and the command put, so the reverse for this one is get command, the opposite command. Move from local, here the command is move to local. So these three commands, what it will do, it copies files from SDFS to local. Okay, I just want to show you the execution of these three commands, so that I'm going to the terminal. Okay, so now here I am going to create a directory in local file system, that is mkdir, and I am writing the directory name test 789, right? I have created, where this directory is created, you can check with the command pwd, present working directory, that is I am in home cloudera. I have created directory test 789. Now I want to move a file from the SDFS. Suppose here I want to move the file input.txt to the test 789. Simple, just write Hadoop space.
Okay, okay,
Yes sir.
okay. So you take the same directory in the local system again.
uh, Directory name is same sir, path is different.
1 minute. You have created the same a directory in the local system with the test 789. And that's what you're saying.
Yes sir.
Can you rename it a different one so that people will know that both are different.
Okay sir, okay sir. Move test 789 to move 790. Okay sir, I have changed that, the directory name is 790. Okay, now I am running the command Hadoop space fs hyphen. So I want to use the command move to local. Now what this command will do, it will move a file to the local file system. Which file you want to move? I want to move the file input.txt. So write this, where input.txt is available. It's available in user Cloudera in a directory test789, and the file name is input.txt. Right, where I want to move this file, I want to move this file to the directory 790. Where the 790 is available, it is available in home Cloudera. So just write slash home slash Cloudera slash then test 790. Press enter. Okay. Oh, we got an error. Move to local is not implemented yet. Right, because we have entered a wrong spelling. Let me type again Hadoop fs hyphen move to local. I'm just checking again. If you write Hadoop space fs, press enter, it will list the commands. Now we can check here, move to local is available. Right, it's available here. Move to local. Right, specify the source and local destination, it is available. Right, now again I'm running this command again. Okay, Hadoop fs hyphen move to local. So which file I want to move? User Cloudera and the test789 input.txt to the 790. It's saying move to local is not implemented yet. So now how to use this one, we have a confusion, right? How we check the syntax for this command? We have a command that is Hadoop space fs hyphen help.
Ajay, 1 minute.
Sir,
I think it's because there is nothing called as test 790. It there is MB 790.
sir, correct, sir.
What?
Sir, correct, sir. The path I have given is the wrong one. Thank you, sir.
Not that one. Okay. At the end, no, that's not
This is
the one.
789 in SDFS, sir.
Yeah.
Right. So now
Change this
test.
here.
Yes,
Test 790.
sir.
MB 7 MB 790 at the end.
Yes, sir. Now it's a test 790 is there. No, sir. Correct. Let me check.
MV. It's not test. It's MV. You have named that
Sir,
MB.
MV is a command, sir.
You are not looking at the what it has been changed to.
Yes,
MV
sir.
is a
MV
command.
790, sir.
Then why are you writing test?
Hmm, correct. Is not implemented yet. Sir, I am writing Hadoop space fs hyphen move to local. Which file I want to move? I want to move the file user Cloudera then test 789, and the file name is input.txt. Suppose I want to move this file to home Cloudera. Just it. I just want to move it to the home Cloudera. Let me check this, it works or not. Uh, it's saying that it's not available. Move to local is not implemented yet. Why it's not implemented? They are saying Sir, I'm checking the usage set. If you write this command Hadoop space fs hyphen help, okay, then write move to local, then it will give you the what is move to local command, right? We have specified move to local, the source in sdfs. Sir, this command is not implemented yet, sir. It's not available, sir, in the cloud era. Okay, suppose if you want to know the usage, move to local, then we have specified the source, then we have specified the destination. Let me, okay, see, I'll try the same with other command. See, I'll check this today and I'll let you know why it is not working. As of now, it is saying that this move to local is not available in this CDH4, but it is available in other versions, where I'll show you the execution of this command. Start taking it. Okay, see, instead of this command, we use copy to local. Okay, it will copy a file to the local file system to the directory MV790, right? The directory which we have created is MV790. Now the file is copied to the MV790 directory. So if you go to the CD MV790 ls, right, we got input.txt. Okay, so I'll check this again, why this move to local is not available here. Okay, that's either right. So here this command is not yet implemented. It's the way the syntax is the correct one. It works with the Hadoop from the Apache, the basic Hadoop version. This command is available, right? If you can see this in the commands list, we have this command is available, Hadoop space fs. See, move to local is available, but it is saying that it's not yet implemented. Okay, sir. Okay, now I'll use other command, right? The same way we have other command, that is Hadoop fs hyphen get, right? So previously we use put command, right, which will copy a file to the local to sdfs. The reverse one is Hadoop space fs hyphen get command, right? So which file I want to get? I want to get file user cloudera, and here the directory Ajay, right? In a directory Ajay, right, I have a file, you can see test 789. So here I have a file 4. Okay, now I want to get this file to the local file system, that is home, in a directory cloudera. Press enter. Right, now this file is copied to the cloudera directory ls, right? We got file 4. Okay, so we have these three commands which are used to copy file from local to sdfs and sdfs to local file system. Okay, so we'll check the next command. right? If you write Hadoop space fs, we'll get the commands, right? We have seen this rm command previously. I just show you again. Rm is used to delete a file. So just write Hadoop space fs hyphen rm, and which file you want to delete, the write the file name, that is user, then Cloudera, and here I have a file test 789. Now if you write the file name, so file 4, I want to delete it, so I use the command hadoop space fs-rm, press enter. Now the file 4 is moved to the trash. Trash is a recycle bin. Okay, so to delete a directory, simply write hyphen rmr. RMR is a command to delete the directory. RM is a command to delete a file. So whenever you write RMR, it will delete the complete directory from the SDFS. Okay. Now, so this file, this directory test789 is moved to the trash. Okay. To delete the files from the trash, which command we have to use? We have to use the command Hadoop space fs hyphen expunge. Hadoop space fs hyphen expunge. So this command is used to delete the files from the trash. It's a recycle bin. Trash is a recycle bin in SDFS. So when you delete a file with rm command, when you delete a directory with rmr command, those are moved to the trash directory. So again, to clear the trash, so we have to use the command hadoop space fs hyphen expunge. So if any files are there in the trash, are going to be deleted. So now I have deleted the file, so there is no file is available in a trash. To recheck, I'm running this command again, so there is no file in the trash, correct? So that command is hadoop space fs hyphen expunge. Okay, rm deletes a file. If you write rm hyphen r, deletes a directory, and expunge deletes files from trash. This is about copying the files and deleting the files. Any questions here? Sami, Sridhar, sir.
No, good.
Okay.
Okay,
Okay. Actually, sorry. Actually, I missed the last one.
sir. Okay, I'll
Which
repeat,
one
sir.
actually?
Right, sir. So whenever we have delete a file with rm command, rmr command, these file or directories are moved to the trash. So it's like a recycle bin in Windows. So if you delete a file in Windows, it will be moved to recycle bin. The same thing.
Okay, it's marked. So that means, can I say that it's marked for deletion? That will
Yes,
be.
yes, sir. It's a permanent delete.
Oh, okay. It's not just marking. Okay.
It's a the files completely deleted from the trash. So RM is deletes the file. When you deleted it, it will be moved to the trash. So now I want to delete it from the trash too, like empty recycle bin. So here the equivalent command is Hadoop space fs-expunge.
Okay, got it.
Okay, sir. Now I'm taking another terminal to check other commands. Okay, so
Is there any reason for changing the terminal?
in, sir, uh, to show you what other commands, sir.
Yeah, I understand. But can we do the same thing in the same terminal now? Why do we need to go
Yes, sir. We can do the same thing in the terminal, same terminal, sir.
No, just we are asking actually.
Yes, sir.
Is there any reason?
Sir, here in the Hadoop, sir, the best habit is for everything which you're working, dedicate one terminal, sir. Suppose, see, if you're working in SDFS, give one terminal for SDFS. If you're working for the Scoop, because we'll simultaneously work with the Scoop. When we import it, we use a scoop and it will be loaded into SDFS. So we use one terminal for the scoop, one terminal for SDFS. This it's a it.
That is the kernel because we want to use the skew. Am I correct?
Yes, sir.
Okay, that I don't know.
So now if you write this, so if you don't know any thing about the command and you are new, and how to you know that the command one is available, help command is available, right? This help command will give you the description about the command. So now I don't know what is expunge. Then write Hadoop space fs-help, then write expunge, then press enter. Right, see,
Um,
expunge
see,
is reader.
uh, uh, see, I'm trying to copy the text file from local to Cloudera.
Okay,
I'm getting error actually. So no such file or directory.
sir, that's yes, sir. Because in the cloud era, you check this pwd. Now you are in this
Hmm.
directory, and the file which you are copying is in the my documents or somewhere. So that
Hmm.
you are getting that error. Okay, just check pwd. Right, you are in home cloud era. Then type ls. So these are the files which are available in home cloud era. That is, now you can able to copy this file. If you want to copy any another file at some another location, you have to write the complete path. Like suppose Hadoop space fs put, and I have a file home cloudera, and in a directory check any the other directory, some directory test, then write the file name, then space SDFS directory. It works, sir, because you have not you're picking a file which is not in the where you're not in the same directory.
Okay, Sami, can you give us the file? What's the application that you are using? Can you tell us?
See, I copied a text file into local. I can see a local text file. Now I'm trying to put into Cloudera HDFC. So the target source is not found. It is actually it is showing the file itself is not found. No such file or directory.
Okay, what we can do is let us see. Okay, if you can share your screen, is it okay, Ajay?
Yes, sir.
Uh,
Yes, sir.
Presenter.
Yeah, I can show that.
Okay, just a second.
Let me give you the
Is it Sami, right? I'm making you presenter, Sami.
No. Actually, you cannot see that because I'm using another laptop for that.
Okay. See, I'll write the steps, sir. Just follow
1 minute.
this, Sami. See,
Uh,
now type first. I'll tell you. Create. Go as this for Hadoop space fs mkdir and created
uh,
some directory. Just
yeah, I
follow.
created.
Right. See, and
These are all okay.
right.
These are all okay. Just
Okay.
copy only.
Right.
Just copy only.
Okay. Now,
1 minute. To know what he did.
sir, I understand his issue, sir. He's giving the wrong path, sir.
Yeah, that's not the question. If it may be a typo, it may be anything. That's what we want to see. What exactly the command is there? What he did?
Okay. The
See,
command Hadoop space fs put is a command.
uh,
Okay,
Not the put. I'm talking about the file. 1 minute, Ajay.
sir.
I tried to put and copy from local.
Adi,
Can you give me 1 minute, Ajay? Please. Uh, Sami, can you please ping that the whole sentence in WhatsApp as is? Is it possible, or take a screenshot from your
yes,
WhatsApp?
yes, sir. That then I'll give you steps immediately.
Sami, can you do that thing?
Hello, Sami.
Okay. See, you cannot type here in this on your screen.
Just
Sami,
type in your WhatsApp.
Sami.
Type
This
it in WhatsApp.
okay. Fine.
Okay, so I think next time I know I'll use the same laptop.
Okay, Sami. Here I'll tell you what is the error because you have picked the wrong file. Okay, So if it is, if right now check pwd where you are in home cloudera. So if you type ls, now you can so you can copy any file directly like hadoop space fs hyphen put.
Okay,
Suppose,
okay. I actually I went into that the folder where the text file is there. Okay.
okay,
Yeah, it is saying / home cloudera LCL SAMI folder. Okay, and I say just ls. It is displaying the text file.
okay,
Um,
Okay.
I think you can ping in the chart window there. In the, if you look at the, with the GoToMeeting, there is a chart window. Did you see that I just now texted something?
Actually,
Maybe you
that was
can.
not shared. Actually, that was not.
yes, the
So
That's
best,
not here.
I'll tell you the
Okay,
best.
okay.
So,
Okay, do one thing. You just continue with this your whatever you plan to.
Ajay, you have to do
Uh,
something.
I'll tell you the best solution for this. Just give me a
uh,
moment, Raju, sir,
Ajay,
sir,
first my please.
sir,
uh,
Okay.
Ajay,
sir.
No.
you continue with your your presentation.
Okay.
Tomorrow I will share you whatever I tried.
Fine, fine, Sami. And meanwhile, just send me a screenshot in WhatsApp. I'll say not this time, even throughout the day, whenever you are practicing, Raju sir and Sami and Sridhar, if you're getting an error, take a photo and send it to me in WhatsApp. I'll try to give you the correct. I'll try to correct in most earliest time. It's just take a photo, whatever the command it is. Whenever you're working, if you get any error, if you are unable to try to resolve it, just send me in the WhatsApp in our group, right? I can
Okay,
identify where the error is, then I'll give you the best solution for that. Okay.
okay, okay.
Okay, sir. Sir, can I continue, sir, with the other comments?
Yes, that's what we requested. Okay.
Okay, sir. Okay, now other comments, right? So we are discussing about help and usage, right? So one thing is, if you know the Hadoop fs hyphen help, then write expunge. It will tell you what is expunge. And if you know how to use this expunge command, then use the command hadoop space fs hyphen usage. Okay, hadoop space fs hyphen usage and then expunge. Okay, then it will tell you how to use this expunge command, right? So you have to use hadoop space, if any parameters you can write, then write the expunge. Okay, sir. Fine. So next I'm going to show you this tail command, right? So tail command.
I got that issue. I resolved it.
Okay,
So what happened now that text file name is a lowercase, actually a uppercase. So I
okay.
was trying a lowercase. Lowercase, it is, I think somehow it is preventing. I put exact uppercase of the name and then it copied.
Oh, okay.
Yeah, actually, this is a case sensitive one. You remember, even Ajay has typed something called as a input option type minus R,
Yes,
Yeah.
yes, sir.
then he had to put capital. So,
See, actually the text file name, no, file name is in capital. Okay. I was giving a lowercase. That is what is the causing problem.
yeah, it should have been solved, but if you have typed exactly, we should have told. Okay. Yeah, that's a good thing. Good catch.
Uh,
Okay. Now see, the tail is a command. Suppose if there is a file in SDFS, I just want to check what are the contents are there in the file, but I don't want to go to that location and to see the file. Generally, in SDFS, we always deal with the big files, right? So I don't want to open the complete file, what the contents are there in the file. So I just want to prefer to see the last 1 KB data in the file, right? Whatever the last end of the file, whatever the last 1 KB data is available, it will display the command. So tail command is display the last 1 KB content.
One quick question. How
Okay.
to go back to the root actually
Just we
from
don't have
the
the cd space dot dot. This one.
okay. Okay, got it. Okay,
Okay.
thank you.
Now write Hadoop space fs hyphen tail command. Then which file content you want to see? Just write user, then Cloudera. Okay, in a directory Ajay. So Ajay is a capital Ajay. Then there is a file ba.txt. Right? Type this. It will display the last 1 KB. Right? Whereas what is the actual content if you want to see? If you write cat, right? It will display the full content of a file, right? This much bigger one. So generally we don't prefer to see everything, right? So I just want to see what the last 1 KB is there. So that we use the command Hadoop space fs hyphen tail command. Okay, it will display the last 1 KB data in a file. Okay, fine, right. And I have another command, that is stat command.
Ajay, why do I want to see only 1 KB? I normally I would like to see either 5 lines or 2 lines. But what is this KB thing doing here?
Sir, because sir, generally we always have the big file, sir. So in SDFS we are going to store the big files. So if you open that files, checking the content, generally we won't prefer. But I don't want to know how the data is there in the file, what data is there in the file. So by writing this tail command, it will show you some sample data, what is the content is there in the file. Because suppose if it is a product underscore info file, so the entire file contains username, product name, price of the product. So now I don't know that what it contains. So if you write this tail command, it will display only the last 1 KB of the content. Okay na sir?
No, sir, my question was totally different.
Sir?
My question was different.
Sir?
Normally, if someone wants to see the file, no, they would like to see like 2 lines or 5 lines.
Sir?
Nobody would like to see in a KB or kilobyte or mega, what called as petabyte or whatever.
Sir? uh, yes sir, here that because this is, sir, that the limitation of this command is we cannot able to specify the number of lines, sir. We cannot able to specify. We have to only one option is there, sir. That's it, only display this 1 KB, sir. And apart from that, we cannot able to change the change, and we cannot able to specify the last number of lines, because in the line X we have both the commands are available. One is head command, other one is a tail command. But in the Hadoop we have only the tail command is available, and the limitation is it will display only 1 KB, the last 1 KB. End of the file, it will display the last 1 KB.
Okay.
Okay, so we have other command start. So start command will display the statistics or information about a file, when the file is created and who is the user of that file, right? Who this user belongs to, which group, when the file is created, how many blocks are there. So everything we are going to check with this command. Suppose if you write Hadoop space fs start, then write the name of the file, right? User slash cloudera slash Ajay. Then it will display the information when this Ajay directory is created. Now I'm going through the terminal to execute this command. Okay, write Hadoop space fs hyphen then start, right? Which file? User slash Cloudera slash, then write Ajay. Press enter. It will display the date and time when Ajay directory is created. Okay, so and sir, I'm going to check this command with ls to show you the username. Hadoop space fs hyphen ls user Cloudera and Ajay. So if you write this, every directory in SDFS will have a I specified with username and group name and the date and time when it is created and name of the file, and these are the privileges. These are the privileges: read, write, execute. So I'll teach
Okay.
you
So,
in
how will you display what is there in x1.java?
it's a cat command. Hadoop fs hyphen cat. If you write cat, then Ajay slash, then write x1.java. It will display. Otherwise, if you want to check the last 1 KB in the file, tail. Okay. So now I want to check stat. Right. Who is the user belongs to this file. So just write
Yes.
percentage u. Okay. Write percentage u will give the username. So this file belongs to which user? Right, this file belongs to the user Cloudera. You want to check this user belongs to which group, then just write percentage g, the same command. Instead of the percentage u, then write percentage g. It will display the group name, that is x1.java in a directory Ajay belongs to the group Cloudera, sorry, new group. Okay, so if you want to display both at the same time, then write percentage u, then percentage g. So it will display this username and the group name which the particular user belongs to. Okay, and if you want to display the size, it is percentage b, the blocks, how many blocks are created. So just write percentage b. Okay, the size is 8602 bytes, right? The percentage base the bytes. And if you want to check how many times this file is going to be replicated, I mean the duplicated, right? So every file in Hadoop is going to be replicated. So now you check how many times it is replicated. The command is percentage r. So if you write percentage r, then it will specify the replication factor for a file. That is, in x1.java is a file, it is replicated 3 times in a cluster. That is, in the 3 different data nodes we are having the file x1.java. So to check that one, we have a parameter, that is percentage r, which specifies the replication factor. So if you want to check how many times this file is replicated, so just write Hadoop space fs-start percentage r and the file name. It will display. So this file replicated 3 times in the cluster. Okay. So this is about the stat command, which will display the statistics, username, group name, the blocks, size of the file, and replication factor of a file. Okay.
So how to find that what are the clusters it is repeated in?
Sir, because generally, sir, only adgatara, sir.
How, I mean, can we, so suppose there are more than 3 clusters. Okay, I would like to know in which clusters this X1 Java is.
Sir, it's
Then only
not.
means
No, sir, we cannot able to see the directly, sir. For this, sir, I am going to the browser, sir. Okay, we know that name node is available in 50070, right, sir? See here we can see I'm having one data node, right? If you click this, right, the data node is in a local host. So if you click here local host, then in the user directory, in the cloudera directory, so these are all the files which we have created. Now which one we have checked here? User cloudera Ajay. So here in the Ajay we have a file. This is x1.java. In this way we can able to check, sir, but directly we cannot check in the disk. We cannot able to connect to the data nodes directly. We have to navigate
No,
through name node,
what did you check now?
sir.
You know, I'm not. My question was, you said that it is there repeated three times. Am I correct?
Yes, sir.
It is in three clusters. Am I correct?
Yes, sir.
So what are so clusters will have some identification. Am I correct?
Yes, sir. Cluster 1, cluster 2, cluster 3.
So that's what how to display that in which clusters it is there. That was my question.
Fine, sir. Sir, this cannot be known to the user, sir. It will be written into the name nodes metadata. So whenever you are replicating a file, we know that the file is going to be replicated three times. So, but in which data nodes the file is replicated, nobody knows. That's what, sir, we call the name node as a single point of failure. It's only written into the name node. We cannot able to see it directly, sir.
Yeah. So now whatever the command you executed, so it's all working. Okay.
Sir,
Ajay, quick question. So you have only one data node, right? But how
yes.
come it replicated three times?
Yes, sir. Sir, the more about this topic, sir, I'll teach you in the architecture session because it takes, right, because we need to know, understand the architecture. So, first thing, sir, Raju, sir, for your question, sir, that's because I'll teach you in the coming sessions in the architecture. I'll teach you. So, what is the replication placement policy is there, sir? So, based upon the replication policy, the blocks are going to be replicated. Fine. And the second one, sir, here I have manually specified this replication, Sridhar. If it is a one data node, the default replication is one. Okay. Hello.
Okay.
So that means you have three copies of this data.
Yes. See, because just again, suppose we are having the three data nodes like this, right? I'll teach you about this in the architecture session because it's a little bit confusing topic. Suppose whenever you are going to write the file, right? So suppose the file name is prod info, okay, dot txt is a file name, and the file size is 1000 MB. Okay, so to make calculation easier, I'm taking four nodes. Okay, so now in the cluster we are having the four data nodes, right? As in the day one definition, I told that we are going to distribute the data. That is, now how it is going to be distributed based upon the block size. Suppose if you are using the block size is 64 MB. Okay, so what is your block size? Consider the default block size is 64 MB, right? That is, what is the file size now? 1000 MB. So if you divide 1000 by 64, right, you will get 15.6 blocks. Okay, now Raju sir, now this file is converted into 16 blocks, sir. The file is not copied as it is, so that we cannot able to see the file. Okay, sir. So now the 16 blocks are created. Now the 16 blocks based upon the your replication policy. If it is a one or if it is three, if it is three, then total each block, that is 16 blocks. No, one is block one, like block two. So like block 16, total 16 blocks are there. So block one replicated three times, and similarly block two replicated three times. Now these all the blocks are equally moved to the all the available data nodes, and this information is only known to the name node. and the users cannot able to see these blocks in the data nodes. Okay, Nasser?
Okay, so coming to Sridhar's question, what is the relationship between a block and a cluster? Because there is only one block. Am I correct? Sorry, not the block. This cluster and this data nodes.
Yes, sir. See, this cluster is a kind of architecture, sir. Generally, how we do, see, now we are having the three disks, sir. So, suppose each disk I have configured in one node, sir. Right? It's a admin will do this. So, each disk will have some disks, right? And we are configured this disks as a nodes, and all these are connected to the name node. Correct, sir? Now, I am the entire this I'm considering this as a cluster. I'm considering this as a cluster, sir. So it's a cluster one where is we're having one name node and we're having three data nodes.
Okay.
Right.
So so therefore, in your apps in the replication node, it says that it has replicated three times. Is that
Yes,
correct?
sir. Yes, sir.
So okay, so within cluster, okay, there is no relationship between the clusters and this one then. In a cluster, our name node, we have data nodes, and how many data nodes we have there? One or okay, okay, it doesn't matter. Okay, okay, okay,
Sir.
got it.
Okay.
Okay, clear.
Yes, sir.
Uh,
Sir, we have a placement replication policy is there, sir. That I'll teach you in the architecture session, sir.
Did you understand that what it is about? It's nothing to do with the number of clusters or number of
Yes,
nodes
sir. Being a developer,
it's all dependent on the number of replications that you would like to have. That's it.
yes, sir.
Sridhar,
Hello?
Sridhar,
Your
did you
voice is
understand?
very low, Prasad.
Okay. I don't know, man.
Yeah, now
Okay,
it's good.
what I'm trying to say is, the number of replications is dependent on the your replication policy, but not on the number of clusters or number of data nodes or any other thing.
No, no, it's yeah, that's I understand that. Yep, I got it when he's explaining. I got it. So yeah,
Ajay,
it could be
Ajay,
if you have three, then it may copy
hello.
three times on the same
Sami,
node.
just a second.
Yeah,
Yes, Sridhar.
yeah.
Yeah, if
See,
you have a replication factor three and if you have only one data node, it may copy three times on the same data node. Because we have only one data node, if you have replication factor three, it copies three times on the same node.
Yes, correct.
Okay.
yeah,
Yes, Sami.
Ajay.
Yes,
Yeah,
sir.
I will tell you the concept behind the cluster. Okay.
Okay.
See, one hard disk is equal to 100 MB. Okay,
Yes,
1 Gbps. Okay,
yes,
and one server is equal to 12 hard disk, which is equal to 12 Gbps.
yes, sir.
Okay, so the one rack they call it contains 20 servers. Okay,
Okay, right.
so the cluster contains 6 racks.
Okay, correct.
Okay, so and it can be up to 200 also, large clusters.
It's up to 1000 we are having, sir, Hadoop clusters.
Okay,
So based upon,
so yeah, the cluster means it is a rack of servers actually.
sir, I'll show you this, sir. See,
Yeah,
sir, this one, sir. So here in each
yeah,
rack we'll have some disks, sir.
yeah. Each rack will have servers actually, servers.
Yes. Here, and Sami, I'll correct you here. So if you're
Uh,
comparing with that rack, Hadoop it's a little bit different because we are using commodity hardware. That is, even
uh,
I'll take my three laptops, yours, mine, and Raju sir, when we can able to configure it as a rack.
yeah.
Right? It's a because Hadoop supports commodity hardware.
Actually, as per definition,
Correct, sir.
six
Yes.
racks, six racks is the minimum. So the average cluster can have 6 racks. Okay, large clusters can have up to 200 racks.
Yes, sir. Correct, sir. Correct. Exactly. Here we have
Yeah.
1000, sir. We can go up to 1000 because based upon your
Mhm.
client's historical policy, half is
See, if you see that rack, the diagram, you have multiple servers in that.
Yes, correct.
Yeah, so one rack contains multiple servers.
Yes. Here we call
Yeah,
the
these are
nodes.
the, see, actually, you need to show this one when your theory class. You are not showing this actually.
Sir, this is in the Hadoop architecture session, sir. So when I'm going to teach you about the Hadoop architecture, I'm going to explain this one and the configurations, all the racks. That's in the chapter 3, sir.
Uh-huh.
Right, in the architecture session, I'm going to teach you all these architectures, sir, how these are going to be,
See,
how the
I
blocks are
think,
placed.
I suggest you one thing, okay? Always theory you display in the screen, okay? Don't come and write there. No, it is taking time, okay?
Yes, sir.
And you make mistakes also. So better you put everything in PPT and just
Yes, sir.
explain that.
Okay, sir. Okay, Sami.
Yeah.
See, today I'll
Yes.
send. Yes, yes, Sri.
Okay. Anyway, that's done, right? Can you
Yes.
make me presenter? I have actually I thought of asking the similar question to you, but if you can make me as a presenter, I'll show something. Then
Okay.
I want to ask some question. Okay.
Right.
Make me as a presenter.
Yes, I did that.
Okay. Show my screen. So what? Can you tell me what screen you see? Do you see my screen?
No, you have to select as a show my screen in the. You'll get
I
some.
did that.
No. Yes. Now. Yes, we can able to see.
Or you can see what
Yes.
screen you see.
It's a Hue and Cloudera manager. Correct. You have
Okay.
opened the
Let me.
browser. Okay.
Okay. Okay. Okay. So this is your. Oops. This is a training thing, right?
Yes.
So I was going through this. Okay. So in this, I think this is the second one or something, your Hadoop thing, right?
Yes.
So you are saying that each circle is a data node, right?
Yes.
And this rectangle is the rectangle is like an each rack,
No, no, no.
right?
These circles are the disks, sir. So and these two disks are in one node. Here, one disk in
Yeah.
one node. These are the disks.
So this,
1 TB
okay,
hard
these are
disk.
the disk,
Yes.
okay, and this everything is in a cluster, right?
Yes. Yes. The
Okay.
together
So
entire
first
works.
question,
Yes.
yeah, first question I have is is a like you generally when you have a system, you have an IP address, right?
Yes.
So every rack has an what is it? Every rectangle has is a system which has an IP address, or a whole cluster has one IP address.
Sir, actually, that's no. It's a suppose this is a multi-node architecture, and each node will have see each. This is the node one, node two, node three, node four, sir. Each
Yeah, yeah,
disk
yeah.
will have its IP address. This one is having its own IP address. This one is having its own IP address. This one is having its own IP address. Suppose when you start
Okay,
the cluster, means I need to start the
uh,
cluster in all the machines, not in one cluster,
no, no,
right?
no. Forget about the cluster. Starting the cluster.
Okay.
Just I want to get just tell me what I'm asking. So each disk is having an IP address, right?
Yes.
So each disk is having an IP address. Then where when you say this cluster, right? Right?
Yes.
So how you what how you what is the IP address of the cluster when each disk has own
No,
IP?
I guess it is all internal. It is a system handles internally. You have
No, no,
only
no.
one.
I know. No, no, okay. My question is whether does cluster as an IP address is the cluster IP address is different from the disk IP address. I know it may be internally managing, but
Sir,
is it a physical IP or is it just internally
yes.
it knows
First,
where it is?
yes. The first answer for this question is we never connected to this data nodes directly. Okay. So you have not given an access to connect to the data nodes. All these nodes are connected to the name node. So now you want to
Oh, I
see,
know. No.
right?
See, okay.
So now
Forget about the connection.
right. If this
Wait.
each
For,
disk name is written into a file called slave file. Okay, in your system in the configuration section, slave is a plain text file which contains name of the all the data nodes, name of the data nodes. Okay, suppose if you are having 10 data nodes in a cluster, then we have the two files. One is a master file.
Sorry, Ajay.
Sir,
Ajay, 1 minute. You did not get the question of. You did not get question. Sridhar's question.
sir.
1 minute. Sridhar,
Uh-huh.
I think the cluster is a logical term.
Yes, exactly, sir.
1 minute, Ajay. Let me. Ajay,
Sridhar.
Sridhar, Sridhar.
Uh-huh. Ah,
You know, cluster is a logical term like a network.
Yeah.
okay.
Okay, the collection of all these nodes will make a cluster. Cluster will not exist on its own as a box. That's what I am assuming. It can be a rack, it can be anything. What is but one thing what I understood is, all the boxes, the rectangle boxes that you have are the independent systems, and all these things, okay, are managed using one more computer where we have something called as name node. All these things are connected like they're like it's like a hub. That's what my assumption is.
Yes, sir. Correctly, sir. Exactly what you said, sir. Cluster is it's a connected as a cluster, sir. But we can't see directly a cluster. Altogether, we are calling it as a cluster.
See,
So,
see, I will tell you in a simple way, the cluster is like a one server actually. So internally it has a many servers inside.
Yes.
So it can have multiple racks and racks have servers. It's
okay.
a
So,
network. It's a linked network actually.
So the network
so
will
when you install the HD, when you say you have to have an SDF, like an Hadoop on every data node, do
Yes.
you
Yeah.
install the Hadoop on every data node, or how you do that?
We have to install Hadoop in every data node.
So that means you have to specify where the data node is, right? When you are
Yes.
installing.
Yes.
That
In the
means it's not internal. It's something that you specify the IP or something. How you specify? Is it an IP? Is it a C drive, D drive kind of thing, or is it is it because if it's C, D, E, then one machine you have C drive, you're just putting a disk, right? C, D, E. Is it like a C, D, E, like in a drives? If
no,
you
sir.
talk about the plane,
These are
or
like
or is it
nodes.
everything as its own is IP?
No, these are all we consider,
one
sir.
thing is every disk will have a IP. You know that, Sridhar.
Okay, so that means every disk has an IP. First thing,
No, a
and
disk will not have IP. You know that, no? A computer, a
that
physical
Host name.
computer
that's
will
what I
have.
want to. That's what I'm trying to figure it out. Okay, so every disk has an IP. So is it every rectangle you mean, or every circle?
Sir,
It is not a disk. That's what I'm saying.
we can
It
have
is
No, no,
multiple
no.
disks in one node. We can have multiple disks in one node.
Okay.
1 minute, sir. Sridhar, Sridhar.
Ah,
One thing. First thing is, let us discuss what is these triangles and circles. Then we'll know easily
yeah.
what will have
Oh,
IP.
yeah. That's why every circle is a data node. Okay, and every rectangle is you said it's a rack, right?
One
Yes,
minute. We'll refrain from rack here. A rack is nothing but a computer. Am I correct?
it's
Or
No,
a
it's a
a set of
collection of
disks.
computers.
Collection of
No,
disks.
no, no. Rack is a collection of servers.
That's a disk, sir. Here we
Yeah.
call it as a disks.
1 minute. Hold on. No, no, no. Ajay, you are confusing. A disk is different from a computer, a server. For example, my computer I can use it as a server where it can have more than one hard disk. Okay? A disk is a physical hard drive. Ajay,
Yes, yes, sir.
అన్నిటికీ సెంటర్ అయింది ఒక నిమిషం ఉండు కొంచెం.
Uh, Ajay, you display that that architecture. You can understand.
Then I need to share my screen. Uh, First,
Okay.
Okay. Share
yeah,
your screen.
just give me a minute. Now,
Are we
so here the rectangle boxes are, we are calling it as the nodes. Okay, so this is one node.
Ajay, Ajay, 1 minute, Ajay.
Are you
See,
sharing something?
No, I am teaching from your screen.
thing is
Oh,
that
did I stop it?
I'll
no, Sridhar, leave it like that. Ajay, I would like to request like this thing. First, we talk in terms of physical things. Just
sir.
suppose we don't see something as a node. What will
నువ్వు
happen?
దూరం ప్రసాద్ నీ వాయిస్ చాలా లో ఉంటుంది.
Avuna. I don't know.
ఇప్పుడు కరెక్ట్ ఉంటుంది. నువ్వు దూరం పోతున్నావా మరి తెలియదు మధ్యలో.
No. What I would like to say is, actually, a computer can be called as a node or a computer, okay, or anything. So let us, stick to one kind of thing. Are we talking about physical design, or are we talking about the logical design? Both can get confused in the that's what I'm saying. The logical is different from physical.
Again you're gone.
I'm gone. I don't know, man. What I'm trying to say is a logical thing is different from a physical thing. So therefore, either we talk totally in logical terms or totally in physical terms.
That is what I was asking. That is what my first question. Where we are
Is it-
talking about logically, where we are talking physically. That's what I want to find. Because whenever you talk,
this diagram, you can understand. Actually, the HDFS, they explain like this only.
which one?
That this you see that data node, and which is it is sitting on a rack 1, rack 2, rack 3, rack 3 like that. So
Okay.
rack means it's a collection of hard disks, maybe a lot of servers contains inside.
Okay.
Yeah. So
Okay.
they they keep different 2-3 copies of the data, same data.
Correct.
That we are forget about that. Forget about that. I'm not talking about that. I'm just talking about architecture. Okay. So now let's talk data node 1, data node 2, and on a rack. Are
Yeah.
they physical disks? Are they virtual?
They are the physical disks.
Physical
Okay,
only.
let's go. Yeah, let's go one by one. Don't because if we try to everybody try to answer, then will be confused.
Okay,
So
fine.
then every data node has an IP address, right?
Yes.
No.
He says yes and he says no.
It's a
Prasad.
host name. Name of
Okay.
that one, host name.
Yeah. Host name is IP address, nothing but IP address, right? Every data node has its IP address.
No.
I have a question here, please. Ajay,
Yes, sir.
IP will be there only for a computer, not for a disk, to my knowledge.
Sorry, sir.
If I have two hard drives in my computer, I will not have two IPs. Am I correct?
Yes, sir.
So here the node is equal to a hard drive, not a computer. Am I correct?
Yes, sir.
Yes or no?
Yes, sir.
Each node will not have their own IP address. Am I correct?
Yes, sir.
Then why are you saying that yes, each
Sir,
data node will have its own
sir,
IP address?
just give me a minute, sir. Sridhar and Sami and sir, the Hadoop architecture, the how you're thinking about your regular cluster is different from the Hadoop, because in the day one I told that Hadoop supports a commodity hardware. That is, the first thing is it can integrate any architecture. It's one thing. If you are looking for the infrastructure, then we can get some disks, like we call it as a data node 1 is a one disk, data node 2 is one disk, and each disk is having its own name, host name, right? So now if what we'll do now, so data node 1 will have some host name, data node 2 will have some host name. So every node disk is having the host name. And suppose if you are starting the Hadoop, means you have to start the name node and you have to start the Hadoop in all the data nodes. That is, Hadoop should be started in the name node, as well as when you run the start DFS dataset, it will start the SDFS in all the data nodes. Then how it will identify in which data node Hadoop is there, which data node is commissioning, because I'll teach you in the coming sessions. It's a commissioning. We have
That's
called
okay.
it.
I'm not.
Right.
Yeah, we are.
Let me complete.
Okay, I'm not worried about that now.
Okay, let me
I'm not worried
complete
about
this.
that.
Now, each data node is having its host name. So we now all these host names are written into a file, slave file. Okay, fine. And the second thing is, if you want to connect it to the this particular data node in rack 9, we are not allowed to connect to the data node 9,
Yeah,
because
I understand that.
the data directly it will not be written, because the data is distributed
Ajay,
blocks,
Ajay,
right? Yes sir.
Ajay, Ajay, one second. So don't go about the how Hadoop stores the data, how it is, because we are not talking about that, okay? Because
Yes,
it's length, it increases your explanation, okay? So
right,
first thing you said, every data node has a host name, right?
correct, yes,
So that you can start and stop,
correct,
right?
yes,
So when you say host name, what do you mean by host name? It should have an IP address, right?
yes, correct.
Okay. So don't everybody don't jump on it. Let's first let him explain what he thinks. Then we can ask. So that means every data node is a host name so that you can independently stop and start,
Yes,
right?
independently,
It's
not
a host.
not
I
independently,
mean,
one data node, it
you can
starts.
you can stop it if you want. I can stop the data node too, right?
If you want to stop the data node 2, we can't stop the data node 2.
Why? You said you can start and you
When
need to start all the data nodes.
Because see sir, whenever you're running this start dfs.sh, right? Did I am specifying that start Hadoop in data node 1, data node 3, data node 5? Correct? We are
Then
not
you said
specifying.
you need to set,
If how many
you need
data
to
nodes are there, all the data nodes
Eh,
it will start Hadoop. When you stop, it will stop Hadoop in all the data nodes. But we cannot able to connect it to one particular data node.
okay, Sridhar, one thing is clear. Either you can start all or stop all at one chunk. It's not that specifically. That's simple.
oh, that I understand. That's not okay. But you okay. When you
Okay.
install the Hadoop, right? When you install an Hadoop, okay, how you install on each data node?
Sir, first see, generally what I'll do, I'll start with the three nodes having, right? Now I have get some more data. Then what I'll do, I'll get one extra node. Okay,
Forget
I'll install Hadoop, and we have a some this disk will have the host name is there, and the name node will have a property cluster membership. So I'll write dfs that
okay. Wait,
I'll
wait,
add
wait,
this
wait,
IP
wait,
address there.
Ajay, wait. Don't extend. Just let me go one by one. So when you need to add a data node, you'll add the data node by installing the Hadoop, right?
Yes.
How you log in to install it? How you connect? Is it like in a D drive, C drive that
No.
somewhere you need to connect to that, right? How you connect to that?
How that's I am saying the connecting it is known as a commissioning. This data node should take a cluster membership from the name node. This there is only one property is there. I'll show you that. See, if you have SDFS, then get conf.
We are getting too far. 1 minute, Ajay. One thing is, Ajay, you need to listen few things.
Yes sir.
What is this? First thing is, what is host name? Is it IP address? Simple question.
Yes sir.
Is host name address?
Yes, host name is IP address.
Okay. So listen. So if my computer, assume that you're assuming that your rectangles or whatever rectangles or squares, is it one computer? Can I consider all these things as each a computer?
Sir,
Can I consider your that rectangles, small rectangles, as a computers, different computers?
these are
Hello?
the nodes, sir. Nodes, not
Not
nodes.
called node man. Can I buy a node outside in the market? No, no. If I
No
go
sir.
and go to go and computer so are these I'm asking you, these are computers, am I correct?
Yes sir.
Different computers? Can I consider each box as a computer?
Yes.
Okay. Then if each box is a computer, can I assume that round things as a disk or a file or something like that?
Yes sir. Correct sir.
So, so that means in general, I know that computer will have a IP address, not the disk. And
Okay.
here also, when you say host name, a host name is something different than IP. You are saying yes, it will have some name. Everything in the world will have some name.
Yes.
Like that, we have names for nodes, but they are not same as IP address. IP use not listening to the term. What is asking IP address? Will a node will have an IP address?
Sir.
Wrong. A disk will have an IP address or not? Simple.
Yes, sir. It will have.
It will have an IP address. So that means it will be like 1.1.1.1. That's
Yes,
what you
sir.
are saying.
Yes, sir. Correct, sir.
So therefore, if so that means suppose if there are two round things, two nodes in on one computer, can we have like that two nodes in the same computer?
Yes, sir.
So that means those two will have the two different IP addresses.
Yes, sir.
Sure.
Yes, sir. Sure, sir.
Uh, Sridhar, did it answer your question that they will have IP addresses?
Yeah, that's fine. I don't think I got it. But let me read something and rack in the clusters before I even talk to.
We are doing now commands. Let's do the commands, and we'll get into this one discussion afterwards.
And
Sridhar, actually, I asked that question, and it's a little small thing.
and a quick answer for this, because one I'll give you two things here, because for a developer this complete architecture is given an abstraction, so we are no way related to the number of data nodes. We have never related, we don't specify the individual data nodes. The first point, please
No, no,
remember
actually,
this.
Ajay, we don't think as developers anytime.
And
No, we are actually normally me and Sridhar are solution architects, so we think more than a developer.
okay, sir. Sir, okay, sir.
So for us, all the subjects is quite normal for us.
Okay, sir.
So
I mean
let
to
me
say, sir, the architecture is they have specified like this for a developer perspective to make the flexibility to the developers, because it's difficult for them to understand the architecture. The complete abstraction is provided. That's
yeah,
I mean to say.
we move on.
And,
Don't worry about that.
and Sami,
Move the-
see that. Just if you click here, live nodes, no, you can able to see the SDFS. Now I am
No,
having
we will not
one
understand.
localhost. That's it.
Ajay, Ajay, please, you said that we will not understand because we did not do the architecture. Now don't do anything.
No, sir,
Again,
I
we
didn't
will.
say it like that, sir.
No, I am saying you said that we are going to talk about architecture in next class. Am I correct?
Yes, sir. Correct,
Then
sir.
we'll do the things then because now you're teaching comments. We'll get back to the comments. Why you want to move on again into a different thing? We'll get 100 questions if we see this thing again.
Okay, sir. Okay,
Are,
sir.
are, are we are we good, Sridhar? That's what I
Yeah,
think.
yeah, I'm very good. Yeah,
Back
very
to
good.
our comments.
Okay.
అరే వర్షం వెలిసిపోయే ముందు